Okie dokie. Sorry, I was getting all my windows set up. All right, so let's do a quick rundown of our timeline and what we've got coming up in terms of a schedule. So today is March 14th. We are now looking at our third milestone. I'm making a note about something real quick. All right, so we're working on our third milestone, which is class diagrams. That's going to be due March 31st. So last class, we went over kind of the beginning stages of class diagrams, what they are, why they're important, what purpose they serve, when they're used, all that sort of thing. And we looked at the basics of creating a class diagram with regard to, you've got the name of the class, and then its properties, and then its methods, and then different ways that classes can interact with each other. We'll review that right at the beginning here, and then we'll get into some completed charts as examples, because that's what you're going to be doing for your class diagram. Okay, and that's the third milestone that's going to be due. And so this is all of the information you need. This is the rubric for how it's going to be graded. So that should be everything that you need to know for that assignment. So that's your third milestone. And then, like the other modules, but there's also a quiz that goes along with this one. Okay, so this class diagrams quiz is short, just like the others. So make sure that you take that. My advice and suggestion for you regarding that is to take the quiz just after we have finished the covering the content of that. Okay, I wouldn't wait until April 7th until you take it, even though it allows you to do that. I would take it right away. And so that's what we've got coming on. You should be working on your class diagram. Make sure you take this quiz. And of course, you have your big project that you're working on over the course of the semester. That is where a large part of your time should be spent developing that application. Okay. So are there any questions before we begin regarding what we just covered or anything else? Okie dokie. All right, everyone is good. Let's hop over to modules. And then we will pop down to class diagrams. The video lecture for last time, so the class recording for the first part of class diagrams is posted on there already. You can check that out. Once we finish today's class, I'll put that up there as well, so that you guys can go back and review that as you like. But let's pop into class diagrams. There's also what these two things are. These are just links to the assignment and the quiz directly here. So you know kind of where it falls. But these are just copied. These are mirrors from what you find in the assignments tab. Okay. All right, so let's get back into class diagrams. We're going to quickly review, and then we'll get into some examples of how this works. Okay, so that's a review of use cases, but let's talk specifically about class diagrams. All right, so first of all, a class diagram has several different parts, and one of the parts is a rectangle that represents a class in your application. You see here, here's more of a completed class diagram, and it has 1, 2, 3 classes in it. But each rectangle has 3 parts. The top is the name of the class, and then it lists all of the properties, or these are the variables or the attributes or the fields, lots of different terms, all refer to the same thing. Having the data type is helpful as well, so you should include the data type. And then the third part is a list of the methods that includes the parameter list and the return type of the method. So for example, this place order accepts an order and returns nothing. Get info accepts nothing and returns a string. Okay. So each class should be represented in that format. And that's the first part. So start by listing all of your classes, putting in all of that information. Yeah. And then once you have each class, we looked at 3 different types of relationships between the classes. Okay, and these relationships are really what the heart of this class diagram is, because it helps us understand how the application works. Okay. Okay, sorry, I've got like a frog in my throat. I went out in the cold this morning. It's like 30 degrees, which is colder than we're used to. And I've got like this frog in my throat, so you'll have to excuse me. All right, so let's take a look at the first relationship. The first kind of relationship is, let me get it. The first kind of relationship is shown here. And this is what is referred to as multiplicity. All right, as it says, multiplicity defines the relationship between the classes. So you see, we're defining the relationship between customer and order with regard to quantity. Okay, how many of one class, how many objects of one class interacts with how many objects of another class. All right, so if we look at this, this is how this is read. All right, so we have one customer places 0 to many orders. All right, that's the order that's done. Okay, it also can be done backwards. So 0 to many orders are placed by one customer. All right, and these relationships are important because it helps define how we set up the coding structure for this. Okay. Continuing that, we have one order consists of one or more order types. Okay. And one or more order items. One or more order items are consisted of one order. Okay. So that's multiplicity. You could have, in terms of options here, you can put 1, you can put 0, you can put 1 to many, which is what this 1 dot dot star means, or you can have 0 to many, which is 0 dot dot star. It's also possible that you have something like 3 to many, or exactly 4. It just depends on the situation, but you can really put any number there. The ones we see up in here are the most common. 0, 1, 0 to many, 1 to many are the most common, although in rare cases you might have a specific number, or maybe it's like 1 to 4, or something like that. It just depends on the actual constraints or features of the application with regard to how many of each you need to put. Okay. Questions on multiplicity. Again, that's a review of what we did last time. Give me 1 second. All right. Is everybody awake this morning? Daylight savings still getting you? Yeah. It's different. And it's not supposed to get any warmer, I don't think either. Not for the next couple of days. Like it's tonight or last night I got down to 30. tonight it's getting down to 26. Thursday's 31, and then it warms up for 2 days and then drops back down to 30 and 28. Unusual for the middle of March. And yeah, I'm still getting used to the time change as well. We were looking at, somebody's got a bill in one of the houses of Congress to make the daylight savings permanent. I would be in favor of that. I don't really care whether we stick with daylight time or standard time. I just don't want to keep switching it. So that'd be my vote if I get a vote. Okay, so let's continue with going through a review. So that's the multiplicity is the first type of relationship between the classes. And again, that refers to how many of one object interacts with how many of another object. Okay, it deals with quantity. The second type of relationship is related to inheritance, and it's a generalization specialization relationship. This is the idea where we have a general implementation and then we have specialized implementations. Okay, so when you have one class that extends another class, or you have one class that inherits from another class, that's a situation where you have generalized and specialized versions of that class. Okay, so here's an example. Bank account. And bank account would be the general. And then these two down here would be specialized. Okay, and a checking account is a bank account, and a savings account is a bank account. And so the traditional relationship between classes in an inheritance setting is still true. This is inheritance follows an is a relationship. But in this situation, we are also looking at it from the perspective of a generalized class, and the bank account or the parent class would be the generalized or the general, and the child classes would be the specialized versions of them. Okay. The way that we show that in a class diagram is by using the arrow. Okay. And so if we look at this right here, the child classes will have the arrows coming from them going to the parent class. That's how that works. Okay. All right, questions on that? That's the second type of relationship between classes, which is the generalization, specialization, or the inheritance relationship. If you are using inheritance in your code base, that should be represented in your class diagram. Now, I will say this. Let's say you're coding in Java. Everything in Java inherits from what class? See if you guys are awake. Close. Main's not a class. Main's a method. Good guess, though. It starts with an O. Correct, object. So everything in Java inherits from the object class. Thank you so much. I asked for some tea so I can quit coughing. Everything in Java inherits from the object class. That is not something that you need to show in your class diagram, because that would be a little bit obvious and redundant and take up a lot of space and make the diagram difficult to read. So only show inheritance when they are classes that you create. Okay, that's kind of a general rule. All right, so let's take a look at the third type of relationship here. And so the first was multiplicity, the second was inheritance. The third is what is called composition. And this shows a whole to part relationship. Okay, and so for example, what we have here is whenever you have a class and there is a variable in the class that is an object of another class, that is a situation where you have composition. Okay, let me give you an example from actual code base. So this is from Axis Football. And you can think of this as any sort of sports game. Here's the idea, okay? Let's talk for a second. We have a class here called team data. And in this game, there are a bunch of teams, okay? And there are a bunch of different properties, characteristics that we need to keep track of for each team. And you can imagine, like if you think about any professional team, there's a lot of information that has to be stored and kept track of and managed for each of those teams. Okay, and so this class, this team data class, essentially is going to keep track of everything. Okay, and this is the actual code that's used in the published game. And so I want to just kind of go through it briefly so you can get an idea of some larger scale object-oriented systems and how they learn, how they work. This one utilizes composition. Okay, so this particular part of the code base that represents all of the classes for managing a team relies heavily on the idea of composition, where the definition for what makes up a team is made up of objects of another class. Okay, so let's go through this a little bit. All right, so for example, there are 36 teams that come with the game. Okay, so when you load up the game for the first time, there are 36 teams available for you to use. And when that happens, or when the game loads up, we create 36 objects of the team data class. There's also an option in the game to create your own team, and you can create unlimited teams. So as that happens, new team data objects are created that represent each of the teams that the user wants to create. Okay, good so far. Any questions on this? Okay. Now, there are also a handful of different parts that each team data object needs to keep track of. Okay, and let's take a look at the first one. We're going to skip down to this one right here, this roster data. And if you notice, there are two roster data objects for each team. The first is the main roster, and the second is the practice squad. Okay, and what this roster data is, first of all, notice the capital letter. This is a class. Roster data is a part of team data. Okay, now roster data can exist on its own, but part of the definition for a team, part of the definition for a team data object comes from a roster data, because you can't have a team if you don't have a roster, players on your team. Okay, does that make sense so far? Everybody good? So a roster, or the main roster, is a roster data, and that, like it says, holds a list of all the players on the main roster, and the other holds a list of all the players on the practice squad. Okay, these are like the people that aren't quite good enough to play, but they just help the team practice. All right, so there's also an array of coach data objects. And so we have, this is all 16 members of your coaching staff. There's also your depth chart, which holds which players are starting in which positions. There's a few objects that keep track of your season stats and your game stats, and a list of team season stats, which holds, it'll keep track of your franchise record for years and years. And then there's data on the team, which is the team file. That's like your team's name. Team play calling, which is how you call plays, and then list of uniforms for that team. Okay. We're going to look just at this roster data. But here's what I want you to kind of see. So we have team data contains roster data. Okay. Does that make sense? We have team data contains roster data. Right. So now what I'm going to do is I'm going to go into our roster data class. All right. So if you are using C# and Visual Studio, if you hold Control, it'll make the classes clickable. Okay. And what that'll do when you click on it, it'll bring it to the definition of that class. All right. So then, whoops, sorry. Now I am in roster data. So I was in team data. Now I'm in roster data. So here's our roster data class. And inside of the roster data class, you see we have two variables, the type of roster it is, the number of players on the roster, and then we have an array of something called player data. All right. And as you can imagine, if team data holds all the information for a team, player data holds all the information for players. All right. So we have team data contains roster data, and we have roster data contains player data. All right. Now, do we see how this is starting to get built together? That what makes up a roster, part of what makes up a roster, comes from the definition or what a player data object is. And the same thing is true for a team data. Part of the definition of what a team data object is comes from the definition of what a roster is. So you can't have a team without a roster, and you can't have a roster without players. Okay. Any questions so far? Okay. Now, when we look here, we see, okay, player data is also an object. And so now let's look at the definition for player data. What makes up player data? Okay. We come in here and we see this is player data, and there's a lot of information. So we've got first name, last name, position, number, skin color, all their attributes, how fast they are, how good at different things they are, how they like to wear their uniform. And then we come down here, we see some additional objects. Now, if you look at the data type of these are simple. These are ints. The names are strings. But if you look and you come all the way down here, we see some additional classes. Okay. So a player will have current injury, a list of all the injuries they've ever had, a list of all the awards they've ever received. And then they've got this player stats. We've got current game stats, season stats, career stats, and then a list of career stats. And so we're going to continue this. Among other things, player data contains player stats. And so you can't have a player that doesn't have player stats. Even if all the stats are 0, part of the definition for a player comes from this definition of player stats. Okay, and so you can see how this whole thing is built. Player stats are needed to create player data. Player data is needed to create roster data. Roster data is needed to create team data. Okay, but this isn't just all, this isn't an exhaustive list of what happens here, because we could, if we were filling this out completely, player data contains player stats. It also contains injury. It also contains awards. Okay, and so this would be a massive class diagram if we were to map this all out, but we could. Okay, I'm just giving you guys a brief example of how this works. And so if we go into player stats and we continue this, we see that these are all of the things that keeps track here. And luckily for us, this is where this particular chain stops. There are no additional classes that make up player stats. So this would stop here. Okay, but I want you to kind of understand a real world example of how this works, which is why I showed it to you. I want you to see the idea of composition, where we use objects as a field or property of a class to help define it. Okay, and so if we go back to the main one that we started with, which is team data, we see we focused on just one of the objects that make up this class. Okay, and we kind of traced it all the way down until we got to know more objects, but we got it all the way down to player stats. Okay, any questions on this?
Professor, I think you're muted.
Yes, I was muted. Thank you. So if we were to do an example, we would put, I'm going to do just a very quick example. So here we had team data. Here we have roster data. Here we have player data. All right, and the way that you draw these is we would have a line coming from the object that is contained to this. Okay, this is how this would work. Right. So if we have this team data, and then we would put, I won't go through all of the things, but we would put the properties here, and then down here we would put the methods. Okay, and we would do the same thing over here, properties, methods, and then we would have a line separating the two. Okay, just like this. Now, the open diamond represents composition. And so what this tells us is that roster data is contained inside team data, and player data is contained inside roster data. Okay, and so what we have here is the composition represented here. But in the, and we're going to look at a complete example in just a second. When you create an actual class diagram, you combine all three of the relationships into one, if applicable. And so, for example, you would combine multiplicity with inheritance with composition if your class structure uses that. And so what we looked at just a second ago with the team data does not use inheritance. There's no inheritance there. And so we wouldn't use the open arrow to show a relationship between the class, but we do happen to use composition. So we use the diamond. If we didn't use composition, we would simply draw a straight line between the two. Okay, that's how you would show the relationship. All right, but we do use multiplicity. Okay, and so for team data, we would say one team data object contains, let's see if I can write this, text would have been better, contains how many roster data objects? Do you guys remember? See if you can tell me. See if you can look through the writing on the screen to tell me how many roster data objects exist here. Two, that's correct. Can you have fewer than two? No. Can you have more than two? No. It's going to be exactly two. So you would put, in this case, two. All right. Now, roster data, if we looked at that, we would see that the inside of roster data, we simply have an array of player data objects. And so it doesn't specifically specify how many we are or how many need to go in there. And so we would say one roster data object contains zero to many player data objects. Because it's possible you have no one on your roster. It's possible that, you know, even your practice squad. So one of the rosters is your main roster. That's like the players on your actual team. And then you have another roster data object for practice squad. And so it's possible you have no players on there. So you have zero to many. You could, if you knew for certain, like in the NFL, for example, there's a maximum of 53 players on a roster. It's possible you do 0 to 53. But this is a little bit confusing because you can't have 53 players on your practice squad. So it's easier just to say 0 to many. Okay. Okay, so we'll leave that 0 to many. All right. Now, if we wanted to go a little bit farther with this, and we go back to the team data class, and I know it's kind of hard to see with all of this. Let's look at team file, for example. So your team file simply, and there's no additional things here. This simply just keeps track of the main information for the team with regard to its name, and that sort of stuff. And so we would put team file here. And so I'm trying to show you kind of how this works when you have multiple classes coming off of a single class. All right, so here we would put properties, and down here we would put the methods. I'm not going to list all of them, but we would again have something like this. Okay, so one team data object also contains one team file. And we would put the others up here as well. And you can see this, the diagram itself would get rather large if we included everything. Okay, especially since we would still need to come out here because a player data object would contain both awards and player stats and injuries, and those would be separate classes off of that. But you could do it all together, and having it that way would give, like if we had this chart drawn all the way out and blown up really big, it would allow someone to look at it and have a really good idea, one, how to code it, but also how to, or how the classes interact with each other, the relationship between the classes. Okay. All right, so let me clear all that and go back to this, close out a notepad. All right, so that is hold apart or composition. And again, these are just some examples here that we went over last class. Okay, so questions for me on that, the three different parts of relationship between the classes. Any questions on how that works? Okay. So, last thing to do is let's take a look at an actual implementation. Okay, so this one contains all three types of relationships: multiplicity, composition, and inheritance. All right, we can just take a look at how they work. So, let's take a look starting up here. So we have a customer class. So a customer, and this one, it's a good idea to put the verb with regard to how these interact with one another. Generally speaking, if you have this symbol, it simply means contains. And so it's not necessary to write those. Like you notice in the example that we were just doing, I was writing contains over and over again because it's kind of redundant to say contains because that's what this symbol means. Okay, but in this situation, you could say a customer places an order. That's just helpful in order to read the diagram. So we would say one customer. Let me get my. So we say one customer places 0 to many orders. Okay, because it would be possible for a customer not to place an order. So a customer exists, but they don't place an order. Okay. Now let's take a look at the relationships coming off of order. So we have, this is called aggregation. Aggregation is another term for composition. It's the same thing. So an order is made up of or contains order details. And the relationship here is we have one order contains one or more order details. Okay, and order details are simply sections of the order. You can see here it makes up quantity and tax status. That would be something like if you go into a store, certain items are taxed differently depending on what they are. And so I think, I'm not entirely sure what it is. I live just across the border in South Carolina. In South Carolina, different grocery items are taxed differently. In fact, I think common groceries aren't taxed at all, but like luxury items are. And I think even across the country, things like cigarettes and alcohol are taxed at a much, much higher rate than other things. And so that's what that tax status would be, or something like that. Then, if we look at this, we see order detailed or 0 more order details contain items. Now, I'm not sure what this represents. Normally, this is inheritance. But inheritance is typically the open one here. I'm not sure what they were doing with this one. And to me, this would make more sense here. I would get rid of this order details and just say orders contain, or one order contains one or more items. And then you would just combine this. This seems like an unnecessary separation. Yeah, I would get rid of this and just put that there. That's what I would do. Hang on. This back to where it was. Okay. So let's go down and take a look at this. So we have order, and then we have the relationship between order and payment. So one order, the verb here might be has or receives one or more payments. Okay, and the payment is simply an amount. But we see here, payment is set up to be a generalized form. Okay, so this is the general, and then down here we have the specialized. Okay, because there are types or specialized types of payment. So it could either be cash or check or a card. And these all extend or inherit from payment. So that's how this would be shown. Okay, so this is a really good chart, except for this up here. This is really weird. Like I said, I would combine this into one, but this is a good example of how inheritance works and how it can be how it shows a relationship here. The order would contain or receive a payment type, and then because cash, check, and credit extend payment, all of those would be valid types to fit in there. Okay, so this shows all three relationships combined together. This is a complete class diagram with the exception of one missing part. And that missing part is a written description. So if you remember all the way back to doing use case diagrams, we had a use case diagram that showed a picture of actors and use cases. But also we had a written description of the relationship between each of those that the diagram represented. And you would simply say something like, this person can do this, which includes this or extends this. And it's just a written description that goes along with the diagram. And so just like we did that for use cases, you also need to do it for class diagrams. And so if you think about the way in which I just walked through this diagram and explained each of the relationships in English, you would do the same thing for the written diagram. So, or the written description. And so you would say something like, at the bottom, you would say one customer places 0 to many orders. Okay, that would be the first thing. So that sentence represents this relationship. Okay, and then later on down the line, we would say something like one order receives, receives one or more payments. Okay, and then you would say cash is a specialized type of payment. Check is a specialized type of payment. And this payment should be type of payment, and credit is a specialized type of payment. So you would do a sentence for each of the relationships specified here. So you need a sentence for here, a sentence for here, a sentence for here, 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 and here. Okay. And that's it. That is your class diagram. That is how that works. All right, that about does it. What questions do you guys have for me on this? So to create the class diagrams, there are some tools. It's a Microsoft application. I don't remember the name of it off the top of my head. You can just draw it in Word if you want, but I believe there are some specific UML applications that you can use to draw it. You can also, I mean, if you want to draw it by hand, that's fine as well. Or even in any sort of application, you can use Paint. Like I said, Word is good. I've even seen people do it in Excel. It's totally up to you. Anything like that is fine. Okay. All right. Any other questions for me? Okie dokie. All right. Well, we will stop there for today. Let me stop sharing.